Okay, in this video I'd like to go over another difference quotient calculation and also show how this applies to finding what we call the derivative. And we're not going to be talking about derivatives in their entirety until the second unit, but at least now we get to see a bit of a preview going into next unit. So let's recall that the difference quotient is a way for us to calculate instantaneous slope. So I'm using m for slope and the subscript inst for instantaneous slope. So we're not talking about average slope or average rate of change, but an instantaneous rate of change, or velocity, as you'll come to see later. So this slope is equal to the limit as h approaches 0 of the expression f of x plus h minus f of x divided by h. Now I'm going to zoom in and then also probably take up 2 lines for each of these calculations moving forward. But that's the definition that we're going to work with. That's the difference quotient. And we're going to try this work for question number 17. Now before I go too far, I do like to do this off to the side first. F of x plus h would look like this. Since the function is x squared minus 2x, then I need to know something squared minus 2 times something. The something, the input to the function, is no longer x by itself, but instead the combination of x plus h. So now I have x plus h squared minus 2 times x plus h. Now you may take the time to expand it like I've shown here, or you might just jump to the FOILed result. After you do this a bunch of times, you'll see that this is pretty common. We're going to end up with x squared plus 2 xh's, or hx, depending on how you label that term, plus another h squared. And then after we distribute in this last term, we're left with a minus 2x minus 2h. By completing this step ahead of time, that's going to help us when we do our substitution in the next step over here. So it's always worthwhile to do that work off to the side. If you do that inside of the difference quotient calculation, I found that it's more likely that you make a mistake along the way, especially while these are new. So again, it's worthwhile to do this off to the side. Now here again, the difference quotient requires f of x plus h to subtract f of x, and the result of that combination should be divided by h. And we've done all of that preliminary work over here, so this section, this group of bracing, is going to represent f of x plus h, which we've simplified to x squared plus 2xh plus h squared, and I'm running out of room, so I'm going to go ahead and erase and make some space for me, minus 2x minus 2h, and from that we need to subtract f of x. Now f of x, this component here, well, that's just the original function. That's the original function f of x. So what I enter here should be the original f of x, whereas over here was f of x plus h. So f of x is simply x squared minus 2x, and we've got that expression over top of h. Well, we still can't, we can simplify further. We can't quite establish the limit yet because, well, we've got this 0 in the denominator. As h approaches 0, there's a 0 in the denominator. It would be nice if we could use direct substitution to evaluate this limit, but as it sits right now, we can't do that. So let's see what happens when we start combining like terms. Now across the numerator, this first group is going to remain unchanged. But in the second group, we're essentially distributing this subtraction sign. So I'm going to write down minus x squared and plus 2x all over h. Now it does get a bit tedious to copy this line each and every time, especially when you see me in class. I'm going to stress the need to retain this limit notation as well. So because of the the fact that it is a bit time-consuming to rewrite all of this, I'd be okay with you skipping steps as long as you are extremely careful when you're identifying items that cancel or that subtract to equal 0 or otherwise. It's really easy to see which terms cancel here, a minus 2x and a plus 2x, and an x squared and a negative x squared. Not quite as easy to see it back here, so if you don't show this intermediate step, you may make a mistake or you may miss something. Those are the only terms that cancel or subtract to 0 in the numerator, so I'll write the resulting components now. So 2xh plus h squared minus 2h over h. And here again, you could probably skip this next step, but I'm going to show it just for clarity here. In the numerator, I've got an h that's common, so I'll factor it out, and I'll show that 2x plus h minus 2 is left in the numerator with an h in a denominator. Now it's real clear to see that those two h's will cancel or factor, reduce to 1. And what we're left with is the phrase limit as h approaches 0 of 2x plus h minus 2, and that is our difference quotient, which will help us find the slope of a curved line. Now this expression here, this one we can use direct substitution. We certainly can substitute the number 0 in place of h, and so since we can directly substitute, we absolutely would if we wanted to use this. Now how this applies to a graph is like this. Here's a graph of that function, f of x equals x squared minus 2x. And here's a point on that function. The coordinate lies here at 1, negative 1. And I may ask you, well, what's the slope of that curve? How steep is that curve? And many of you might visualize in your head, well, it's perfectly flat right at that spot. It's pretty steep, but it's kind of dropping as we come from left to right. Then we hit this point here, and then it turns upward, and it starts to get steep again. So if you had to make a guess, it's perfectly flat here. And as it turns out, the slope of a flat line, if we had this tangent line representing the steepness of this curve, well, the slope of this flat line is 0. How does that work with the difference quotient? Well, with the difference quotient, we said that the slope, when x is equal to 0, so let's say something like this. We can use all kinds of different notation, and this is pretty common. The slope, when x is equal to 2, would look something like this. The limit, as h approaches 0, of 2 times, oops, sorry, not when x is equal to 2. What am I talking about? The x value was 1, right? Here the x value is 1. So at this point we have an x value of 1. All right, so 2 times 1 plus h minus 2. And since we can directly substitute, there's no quotient violation or anything like that, we can directly substitute here. This would be equal to the limit as h approaches 0 of 2 times 1, which is 2, plus 0 minus 2, and the limit as h approaches 0 of 0 equals 0. Since h is gone, the limit of this number is that number itself. And again, this was our way of calculating the slope at x equals 1, and we're saying that the slope is 0. So our intuition said that the slope should be 0. It should be flat here. And as it turns out, we were entirely correct. The slope is 0 based on the graph and on our calculation. Now if I reset and start talking about this point when x is equal to 2, well now we've got a different slope of this curved line, and that might be a little bit harder to see. Now I took a screenshot of that and I'll try to paste it here. How do we show the steepness of that line? I mean, we've got lots of different options here. Let me pick a color that'll stand out a little bit. We might guess that the tangent line looks something like this. I think that'd be a pretty good guess. If you're not very well practiced on drawing tangent lines to curves, this is an old geometry skill, you might say, well, this line kind of looks like it's tangent at that point. Or maybe not. Maybe I can do a little bit better if I can move it. But you get the idea. This tangent line has to bump into this curved line right at that point in such a way that it just glances off of the graph and turns away. Well, there is only one tangent line for any point on a curve, and our objective is to find the slope of that tangent line. So I'm going to place mine right about here. I think that's pretty good. This orange line touches the graph right at this point. It glances off of that curve and doesn't turn away, but it glances off of that curve in such a way that it is representative of the tangent. Now, if we did draw this correctly, and if this coordinate, or if this line lands nicely on a series of coordinates, we could determine its slope or its steepness by just counting rise and run. And as it looks like to me, we've got a change in y equal to 2 and a change in x equal to 1 on each of these steps. So I would argue that the slope is equal to 2 over 1, and we've got a slope of 2. That's what I would guess by looking at it. But here again, if our line was drawn incorrectly, or if that line didn't cross any of our grid lines very nicely, well, it would be very hard to determine that slope. And so utilizing the difference quotient would be pretty helpful. Now, speaking of difference quotient, we can use the exact same formula. This time we'll say the slope when x is equal to 2 is the limit as h approaches 0 of 2 times 2 plus h minus 2. And some of you might already see it. If you haven't already figured it out, you can go ahead and make an estimate of what this is going to look like as we simplify. But using the same process as before, direct substitution for h, simplify the expressions as we can. So now the limit as h approaches 0 of the number 2 is equal to, quite simply, 2. An educated guess based on the graph led us to believe that the steepness at this particular point was equal to 2. That's what our guess was, and now we've confirmed that with an actual calculation. There it is. And finding the steepness of a curved line is super, super important because the steepness changes all the time. How steep that curved line here was different than what it was here, which will be different than what it is over here, or here, or here. And that, in a nutshell, is the study of calculus, how we find the steepness of a curved line. And as of today, and through next week, the difference quotient is the tool to get there. Hopefully this video helps, and if you have any further questions, please make sure to send me an email or a message through Schoology. We can set up a time to chat, or I can record additional videos to help explain a concept. Thanks for watching.